Let's talk about Docker. It has really changed the way we develop software and ship to production. The companies became more agile and they can adapt more easily new technologies. All that because we have now super isolated environments in our development and in production. So today let's discuss what exactly you have to know in order just to get started with Docker, or what you have to know in order just to build your cloud environment, or even just to develop a basic software environment on your local machine. So there's a few concepts that you have to know in order just to get started with Docker. Otherwise you will just burn out your mind to understand what kind of terminology to use to speak with developers, or even to understand the documentation that is available online. So stay tuned and don't forget to subscribe. So to understand the concept of Docker, you kind of have to understand the principle of why we actually want to have an isolated environment inside our operating system. So it really depends on a unit of the process that we want to execute. For example, if you have a different versions of Python or Node.js, sometimes you have a specific requirements for your environment in order to just to survive for your application. And because, for example, if you want to have different versions of Python, you have to set up virtual environment, which is very similar to what Docker offers. But instead of having just a file system isolation as virtual environment is doing, Docker is really isolate entire process, which means that on a host machine, you don't have to have all of the libraries installed that you need for your process execution. Instead, it just picks up whatever you have inside your Docker container. And that's really one of the main goals that Docker developers initially tried to achieve, is the ideal isolation, but without the cost of the storage. For example, virtual machines previously achieved that kind of isolation, but you had to have entire operating system functioning in order just to isolate a single part of the software. But with Docker, you really get the full isolation without need of installing the entire operating system, which costs you a lot of memory and a lot of storage. And also, of course, in the deployment process, it's painful and really time consuming. So Docker really solved all of that issues related to storage, and it's really lightweight as isolated environment, so that right now you can have multiple development environments in your server. You can install dependent software and without thinking about versioning or cleaning them up later on. You just can remove a container. That's mostly it. To understand also the history behind Docker, you have to know that Docker is not an inventor of containers itself. The idea exists in more than 10 years, and Linux and BSD operating systems had them for a while now. But before Docker, it's really hard to configure. It was really hard to configure the environment for the containers, and it really meant a lot of development work in order just to get started with all of the scripts and operating system requirements with Linux kernel, etc. But with the Docker, they really standardize it all the way, how you configure your container and how you manage them. So essentially, Docker is providing really nice CLI to work with containers, but it really uses under the hood LXC called container engine, which controls entire containerization on Linux machines. That's why natively we don't have Docker containers on Mac or on Windows. They always come with the virtualization of, let's say, VirtualBox or other virtual environment, Hyper-V, let's say, on a Windows. So that's the backstory of a Docker. So let's just straightly run to the command line and execute some commands to understand really what is the terminology and how you actually execute a Docker container and what is under the hood working. So to understand better how Docker containers actually execute, you have to know that, for example, on a Mac, I'm using currently a Mac. On a Mac, you don't have like exactly Docker process, Docker daemon running on your environment at the moment you execute a file, execute a Docker command. It actually picks up a virtual machine which runs a boot to Docker thing, which is kind of Linux with very minimal stuff in order just to execute a Docker. So that's the ideal condition if you want to run it on a Mac. That's probably how you are going to run it, because by default, like a Docker itself provides an official distribution from that. So overall, Docker is really, really simple command line interface, and you can type just a basic help, and it really provides you with all of the necessary commands in order just to execute and run your environment. Like I'm using mostly for the dev environment and in production. There is a couple of things that you have to know in order just to understand the overall concept of the Docker itself. So there is a repository, there is a tag, there is image ID, and to understand better, let's say we are trying to pull Docker pull, we are trying to get a remote Docker image. Let's say we are trying to get a Python, and we want to get, let's say, Python 3 with Alpine. This is going to pull from Docker Hub, and the actual Docker image maintained by the official Python 3 community, and it's kind of, there's a strict rule for the officials. They are tagged, so you can like make sure that the image is officially maintained before pulling it out if you care about that. So to understand better the terminology, in this case, so the Python is the repository name. So whenever you reference a Python, it means that it is a repository. So that could be also, let's say, a remote repository, which is not a Docker Hub itself, which is by default. But you can, for example, reference repo3scale.com/Python, which is basically a repository which is not a Docker Hub, but still you get that from the naming, and you probably will have something like that if you make a local setup on your environment, and Docker provides all of that imaging things to make your local setup. But first name is repository. Sometimes in some documentation parts it is referenced as an image, so be aware of that. Like first part is naming is a repository, and second part from this is like a tree Alpine, it's a tag. You can see it here, but again, like one of the major confusions is that most of the Docker documentation refers tag as an image. So the actual image consists in combination of repository and the tag. So that's the way how I like to describe this kind of stuff. So in order just to understand what is image is the end point for getting a container. So to get an endpoint, you are just basically have a naming with a Python and the Alpine tag. So that's kind of like how I like to describe and how you can understand this kind of naming. And to put this in perspective, Docker image itself contains a lot of like layers, and you can watch them out like typing inspect and an image. There is a ton of layers which mostly like consist in base operating system, which is Alpine. Maybe there is some other scripts that are installed, and inspect command giving all of that, and you can just watch over what kind of like configuration has this 3 Alpine Docker image. And to run this, let's try it out. And -it, which means we want to get an interactive mode for the input and output for the CLI, and we want to get that Python 3 Alpine image, and we are going to execute sh. So Alpine is a kind of base image for the Docker, similar to like Ubuntu or Debian Linux distributions. The Alpine is the minimum, bare minimum things that you need to run a Docker container, which means like it's about 25 megabytes or so. And I usually like to use Alpine as my base image because it's so small. Instead, like compared to Ubuntu, let's say it's 300 megabytes or so, which is kind of insane. And by running this out, you basically have now the Docker container, and we are inside that container, which contains all of the like files, and I can freely remove all of these files. It's kind of like stupid in a way, but like you can remove it and type an exit, and you don't have like any damages on your environment, because it's again like totally isolated environment. And this is the like main concept that you have to understand in order just to execute a Docker. So to get a list of containers, you have to type, let's say, docker ps -a. It gives you all of the containers that are exited, or like you execute it and it's running right now. And to get an information about your container, let's say you want to grab an IP or understand what kind of environment variable it contains, you have to run docker inspect. So to understand better what I mean when I say it is really the isolated environment, it means on a Linux kind of environment, it means that it has its own environment variables. So entire Linux configuration, like most of the configurations, come from environment variables. So you really can configure your software or Linux, how it runs, through environment variables. So if you provide different environment variables, you get a different environment. So that's really basic explanation. But here you have a different Linux distribution running with a certain set of environment variables defined. So you really have a completely different environment running here. So deleting any files with a different file system doesn't really matter. It isolated from your file system. So this is the lightweight introduction into Docker. Stay tuned and don't forget to comment below to understand better what kind of things you want to look up for the Docker